Hello friends, today we will discuss about the Desmos software. It is a free graphing calculator available on the internet and it is used for drawing the mathematical functions on the computer, the graph of all the mathematical functions. So in the address bar we will type www.desmos.com and this web page will come in front of us where we will click on the graphing calculator. This interface will come in front of us, and this interface is the interface of this graphing calculator where it is divided into two parts. The first part is the equation area where we will write our mathematical functions and equations and whose plot will be done over here by the software. This is the plotting area. You can see the axis over here, the horizontal and the vertical axis. So suppose if I want to plot say y is equal to sine of x. So this is the sine function. Suppose I want to plot y is equal to cos of x. So this is the cos function. Suppose if I want to plot a straight line, y is equal to x. This is the straight line. I can also plot y is equal to minus x. Just the direction is changing. Also I want to show that y is equal to x plus 2 parallel with y is equal to x. Suppose I write y is equal to x minus 2. It is below y equal to x. So similarly, similar kind of examples and experimentations can be done. Suppose I want to plot a parabola, then I will write y is equal to 1 by 5 of x square. This is a parabola, you can see. A parabola has appeared. Maybe due to some background graph of other functions, it is unable to see. So what we will do, we will keep clicking on this, and in this we will choose the line pattern like dotted. We will increase the thickness to suppose say 8. Now it is easily visible. Still not visible, then we can switch off the other functions like clicking on this. The other functions will get vanished and we can see our own parabola. Again keep clicking on this, decrease the thickness to 4. This is the parabola. If we want the other functions back, we will again click on it, the other functions will appear. Suppose I want to draw a circle, then what I will write, y square plus x square is equal to 2 square. This is the function whose radius is 2 units. Now suppose instead of 2 I write r square, then this r is a constant. So Desmos is asking me to add a slider. I will click on it, then a slider comes in front of me. Here I can see that if I increase the slider, the circle is also increasing. If I decrease the slider, the circle is decreasing. Why? This slider is very helpful. It helps to oscillate the values between two given ranges. So in this range, suppose if I oscillate the values to a positive direction, the values will increase. So the radius is increasing. So the circle area is also increasing. So it's similarly happening with the reverse order. When I am doing in the left side, the value of r is decreasing, so the circle's radius is decreasing, so the area of the circle is decreasing. This is called the slider. Any constant can be inserted through a slider, the value of constants. Now suppose another feature of this is like suppose now all these things I don't require, so I am deleting all these things. This is y is equal to sine x. Instead of y, I am giving it a function like, let's say, f of x is equal to sine of x. Now I will click on this icon. Here you can see there is one option given as convert to table. If I click, then all the values of x for which the corresponding fx, it will be displayed here in table. The values of x and its corresponding values of fx will be displayed. So these are the discrete points from the graph. Suppose I want more rows to be inserted, then I will press enter. More points are coming, and so many points are getting marked also. All those points seen over here are getting marked here with the dots. Suppose I want to delete some points, so I will press the backspace. Suppose I want to know the value of this function at pi, so I will write pi. The value of this function fx at pi is 0. Why? Sin x at pi is 0. Suppose I want to know at pi by 6, so it is 0.5. Where is this pi by 6? This is this one. If I zoom it, No, this is the pi by 6, that is 0.5, it is coming. So all the points are getting marked. If I click on the points, the location of that points will be shown. So this is how discrete points can be means plotted using the table function of this Desmos. Now I switch off this one and I keep pressing on this. Here I can get options like choosing the circle instead of dot or choosing the cross instead of dot. Suppose I choose the circle and I increase the thickness to 15 and change the color also. Suppose I don't want to see the lines, then I can click here. Only the circles will exist, circles will come, the lines will vanish, the circles will be only seen. Suppose I want to see the lines only and not the points or the circles, then I will click here. Then the then the points or the circles will vanish. Now circles are also there, points are also there. So these are the basic functionalities and settings that we need every time. So this is the sin x. The graph of sin x is not appearing because it is switched off. I will click here once, the graph of sin x will appear. Now this is the graph of sin x. So we know that the value of sin x, that is the graph of sin x, oscillates between 0 to 2 pi. But here the marking of the x-axis is from 0 to 4 like this in numeric values. So we want the marking of the x-axis in 0, pi, 2 pi in this format. So what we will do, we will go to the settings and here first of all we will choose the arrow. Then in this axis, x-axis part, we will write minus 2 pi. It will start with minus 2 pi and go up to 2 pi. And the step that I want to choose is pi by 4. That is, the graph will be divided into pi by 4 sections. And I click OK outside. Then you can see the graph is oscillating between 0 to 2 pi. Again the graph is oscillating between 2 pi to 4 pi. Again the graph is oscillating between 4 pi to 6 pi. So we can see the oscillating behavior of this sin x curve over here. We know that the highest value is 1 and the lowest value is minus 1. So this is the local maxima, you can say, or the global maxima also for this sine curve, and this is the local minima or the global minima for the sine curve. So you can see the maxima and minima values are always in gray color, and if you click, you get the actual actual location of those points. Now this is fx is equal to sin x. Now suppose I want to differentiate this, then what I will write? D by dx of fx. So after differentiating sin x, we know the answer is cos x, and you can see the plot of cos x has appeared. That means the derivative of sin x is cos x, and the plot of cos x has been done by the software. Now we will see some other features. For this I am opening a new blank graph. From here, if I click once, I can change the name of the title. So title means the name of the file. So I am making the name as tutorial, tutorial tutorial _3, and I will click on save. Now let's see some other features like y is equal to x square. Y is equal to x square, but I want to see the values of y is equal to x square, only those values that are less than 0, that is the values of x that are less than 0. I want only those to be plotted. Then what I will write? I will open one curly brace and inside I will write x less than 0. Therefore, only for those values of x which are less than 0, y is equal to x square has been plotted, and this is that output. You see, for the x greater than 0 part is not plotted, x less than 0 part has been plotted. In the next step, I will write as y is equal to x for only for those values which are between 0 and 2, only for those x values that are between 0 and 2. So I will write 0 is less than x is less than 2. So the plot for this y equal to x is for only those part for which the value of x is starting from 0 and ending at 2. So it is between 0 and 2. Again in the next part I want to see plot y is equal to 2. This is the plot, sorry. Again in the next part I want to plot y is equal to 2. So y is equal to 2 is a straight horizontal line parallel to the x-axis, but I want only the values between or starting from x greater than 2. So x greater than 2 values are only plotted. You see the values that were less than 2 are not there. The values for the x that were greater than 2 are only plotted. Now what is the basic reason behind this? This feature is helpful while plotting piecewise continuous functions or step functions and jump functions. So these features are helpful in plotting the piecewise functions, where the function's definition has been given in 3 pieces. That is, from x less than 0 it is x square, from 0 to 2 it is x, and from x greater than 2 it is 2. So this can be plotted. Now the question is the function continuous at x equal to 2? So what I will do, I will bring my pointer at x equal to 2 at the given line of the function and see the values what it is trying to show. It is showing 2 comma undefined. Why 2 comma undefined? Because it is x greater than 2. So the point 2 will never be attained. In fact, all those points that are greater than 2 will be attained. Therefore the function is discontinuous at x equal to 2. Also, because the function is undefined, because this function is undefined, therefore the function is discontinuous at x equal to 2. Also, at x equal to 0, the function is again discontinuous, because in nowhere it is written x less than or equal to. It is always x less than 0 or 0 less than x less than 2. That means at 0 the function is undefined. At 2 also the function is undefined. So this given function is not continuous. Though graphically we can see that this is not continuous because it is not defined at that point. So this is how continuity and differentiability can be taught to the students using Desmos. Now suppose some important functionalities of this Desmos. Suppose I want to plot some implicit functions. Implicit functions means say 2x plus 3y is equal to 6. This is an implicit functions where x or y values are not taken separately, rather they are the part of the equation itself. So 2x plus 3y is an implicit function equal to 6. Again 4x plus 17y is equal to 2. So these two are simultaneous linear equation. 2x plus 3y equal to 6 and 4x plus 17y equal to 2. These are two simultaneous linear equation. We know that the solution of these two linear equation will exist. Why? Because these two linear equation are cutting each other, that is, they are intersecting each other at a point. What is that point? We will click here and we get the values of x and y at which those two lines are intersecting. So this is the solution. So while teaching simultaneous linear equations to the students, this property can be explained. So this given question, that is, if these two were simultaneous linear equations and we had to solve it, then there the solution would have exist, and the solution is x equal to 4.364 and y is equal to minus 0.909. Suppose a question is given as 2x plus 3y is equal to 6 and another question is given as 4x plus 6y is equal to 12. So basically, can you see that both the functions are overlapping each other? Both the functions are overlapping each other. That means these two functions are linearly dependent. These two simultaneous equations are linearly dependent. That means they will have infinite number of solutions. These two linear equations will have infinite number of solutions. This is how we will explain graphically. These are having infinite number of solutions. Suppose take another example. Instead of 12, I am writing 15. And I plot it. Now see what happening. I wrote as 15. So these are these two simultaneous equations, when plotted, they are parallel. They are parallel to each other. That means they are never intersecting. That means these set of simultaneous linear equations will have zero solution or no solution. So there are three cases existing. Solution will exist, infinite solution, no solution. So the solution will exist only if they intersect at a point like this. Solution will never exist when they are parallel to each other. Infinite solution will exist when both the functions are linearly dependent, that is in this form, that is this is the twice, this function is twice of this function, so they are linearly dependent to each other. So infinite number of solutions will exist. In this case no solution will exist, and in this case single solution will exist, that is the point of intersection. So this is how the chapter simultaneous equations can be taught graphically. Also some more important features, like suppose if I want to plot x square minus y square is equal to 1. This is a hyperbola. This is a hyperbola. You see, this is the plot of an hyperbola. Now I am plotting a circle inside this hyperbola, so I will write x square plus y square is equal to 1. See, a circle has been plotted inside this hyperbola. Suppose another important functionality I want to show, like sine of x plus y, sine of x plus y times cos of x plus y is equal to, say suppose I want to give it a value like u, and this u is a constant, so I will add a slider for it. Now this value of u should vary from 0 to 1 with the step function as 0.01, and I click outside. So a slider has been created. It is not getting slided. I think I have done some typing mistake. It is 1.01. It should be 0.01. Sorry. So I will click outside. Now see, as I will increase the slider, how the graphs are getting connected. That is for sin x plus y and plus sin x plus y, and then here I have to give minus. Sorry. Now what I will do, I will switch off this one to show the output. Yeah, now see, this is the output of sin x plus y times cos x minus y equal to u, where the value of u is right now 0. If I increase the slider, see, this is how it changes with the value of u when the u is oscillating between 0 and 1. So sin x plus y cos x plus y when equal to 0 gives me a grid lines of square, and as the value is increasing to 1, you can see it becomes circular in nature. I pause it. You see, when it was 0, it is a square grid. Again when I increase, you see how the grids are detaching from itself and they are forming. So basically what we do is, instead of giving this slider, we generally write 0.25, and this is the pattern that will appear. The graph of sin x plus y cos x minus y is equal to 0.25. Now we will switch on other functions also. This is the complete output. Now suppose I want to plot some inequalities. How to solve inequalities? Suppose the question is y is greater than x plus 1. So x plus 1 means, the question is saying that y is greater than x plus 1. That means the line y is equal to x plus 1, that is the line y is equal to x plus 1. All the points on the line y is equal to x plus 1 is not included. Since it is not included, we are using a dotted line to show that the line y is equal to x plus 1 is not included. So instead of writing less than, y is greater than, instead of writing y is greater than, if I write y is equal to, then you see it becomes straight line, because that point is all, the points on that line is also included. Also, this inequality cutting the x and y axis is shown highlighted. If we click on it, the points will be displayed. Suppose another inequality, suppose this was from previous, it was less than, greater than, y is greater than x plus 1. And now suppose another inequality I want to add, that is x square plus y square is less than or equal to 1. This is a circle. This is a circle. Again, suppose I want to add like this, that 0 is less than equal to x is less than equal to 3. So all those points between x-axis, all those points between the x-axis, that is between 0 and 3 are shown. So it is a vertical plane extending from minus y to plus y in the axis. Suppose I want to write f of x is equal to x square minus 1. This is a function. I close other things. Now see, this fx is equal to x square minus 1, and this is a circle. The points where it is touching the circle has been highlighted in gray, and we can see it easily. Suppose I am writing another function like g of x is equal to x minus 1. So it is showing this one. Now I'm switching off this one. Now I want to see where this point, where these two graphs are intersecting. It is highlighted in gray color. The points can be seen by clicking on them. Now I want to shade this intersecting region, like in the chapters like area under the curve in class 12 integration. We used to get this kind of questions, and this we have to find the area that is common to both. So we have to, first of all, we have to shade this area for denoting. So how we will shade this common area? So for shading this common area, we will write f of x is less than y is less than g of x. So you can see only that shaded region has been shown that are common for both, that is all the y values that comes between fx and gx. Now it has to be seen that fx is a greater function and gx is a lower function. Why fx is greater function? Because at this given point, the point where we want to shade, the fx comes above gx. So fx, the values of fx at this point is greater than the values of gx. So we want all the values between fx and gx. So we will write fx less than y is less than gx. If you had written the opposite, that is g of x is less than y is less than f of x, then the outside regions would have been colored, the outside region, but we wanted the common region, therefore we had to change the ordering pattern. So that's all for today. I hope you liked the video. Thank you for listening. Next, in the next classes, I will bring about how to do the polynomial regression and some things more on the implicit function and function of functions, parametric functions. All these topics will be covered under in the upcoming videos. Thank you.